How many of you solved? Who will tell me? This example was given for the homework, right?
Yes, sir.
Huh? Yes, दिला होता ना. So how many of you solved? How many of you solved? Should I take one by one name? Hmm? Okay, Snehal, what was the answer?
476 RPM.
Okay, option A. Okay, and
Yes.
who will tell me another one? Kumar.
Yes, sir.
What is yours?
476, sir.
Okay, same answer. Okay, Sachin, Rajeshri, Prashant.
476 RPM.
Okay, all are option A.
476.
Yes, sir.
Okay, okay, fine. Let us see. What about others? Anmol, Anmol, unmute yourself. Why you have not solved?
Yes, sir.
Have you solved?
Option A.
Show me your answer. Send in group or send me personally. Hmm? Anmol,
Yes, sir.
send it me immediately to my WhatsApp number. Okay? Okay, fine. So the question I will read again: a 220 volt DC shunt motor runs at a 500 RPM when the armature current is 50 ampere. Calculate the speed if the torque is doubled. So this is the given data, and in that it has given to you all about the voltage is given, then also speed is given when armature current is 50 ampere. So that time all information is given, and also what I asked when torque is doubled, then what will be the armature? So what will be the speed? Okay, so let us go for the example. So first step that will be what we will do. We will take a given data that is a 220 volt, that is a 500 rpm, armature current 50, armature resistance 0.2 ohm. So at that moment we know that back EMF is equal to V plus IARA, but that V is nothing but what? KA5N, right? So we can put all the values here, we can calculate value for the KA5, right? So once we will go for the KA5 value, that time we will get the value. That is the value, and we know in DC shunt motor, torque is directly proportional to the IA, but we will write it is equal to, so there is a proportional constant. So torque is directly proportional to the IA. So when torque is doubled, what will happen? Your armature current will also double because they are proportional to each other, right? They both are proportional to each other. So once there will be a change in torque, your voltage armature current will also change, right? So now we will see the new speed. So 220 is equal to Ka phi n1 because we know that our armature current and torque both are proportional to each other, right? So with that help we can find out the value for n1. So n1 will become 476.19. So round figure it will be equal to 476, and it is right A option. Okay, so this is all about the whatever the data they had given to us. We have to solve it like that. Okay, so now the next is Yes, we will read the example. Rushikesh Vatare, please read the example. Rushikesh, can you hear me? Okay, who will else? Gauri Patil. Yes, read the example. Gauri, am I audible?
Yes, sir.
Yes, read the example.
Determine the torque developed by the armature of a 4-pole DC motor having 774 conductors, two paths in parallel, 24 meter Weber of pole flux, and whose armature current is 50 ampere.
Fine. So they had asked us the value for torque when motor having a 4-pole, 774 conductors, two parts in a parallel, 24 milliwebers of fluxes, whose armature current, that is IA, is also given. So all these data is given, right? So with that note, we have to solve the exam. Okay. So let us try to solve. Yeah. So first thing, we will write all the data whatever they had given. Okay. First of all, we will write down the data. Yes. So P is given, Z is given, A, phi, and IA is given. So just do one thing. In this formula, as we know that EB is equal to phi P and Z divided by A. So in that formula, you just place the values immediately. Just insert all the values and solve the example. Yes. Abhay Kumar, is it? Can you solve? Abhay, am I audible? Okay, fine. Let me solve that one. Okay. So here we know that EB is equal to P phi ZN divided by A. So we can write this into that N, we can convert it into omega. So that is why this 2 pi will come to this, means we will just convert this N into the radian. Okay, so that will be the omega by 2 pi. So we will write PZ 2 pi A phi omega as it is. So as we know that the constant EMF we have to calculate, that is equal to Ka is equal to 2 phi. So that is written as a K. Okay, so now P, we know the value of P. Okay, so what is the value of P? That is the 4. That Z is nothing but more, that is the conductor, 2 pi into 2. So like that way we can calculate the constant EMF. Okay, so this is the first step. So next step we will continue again hereafter, that we know torque is directly equal to K into uh, K phi IA. Okay, so that means 246 into that phi value is given, that is 24 milliwebers. IA is nothing but 150. So like that way we have this data, that is 295.6. Okay, so as we know that for the DC shunt motor, DC motor, the formula for torque is nothing but what? That is equal to Ka into phi into Ia. so 295.36 Newton meter, that is the right answer. So option C will be the accurate. Okay, so like that way examples will be asked to you in the gate examination. Next again we will take, that is a 200 volt DC shunt motor. You can take write it down. Okay, you just write it down. You just write it down. Just tell me once you complete. Or take a screenshot also. You can take a screenshot also. Okay, so now see, 200 volt DC shunt motor running at 1000 rpm takes an armature current of 17.5 ampere. It is required to reduce the speed to 600 rpm. So what must be the value of resistance to be inserted in the armature circuit if the original armature circuit is 0.4 ohm? So now let us take these all value. See, voltage is given, that is the 200 volt. Okay. Then speed is given. We can say that is the N1 is equal to 1000. Then armature current is given, IA. So IA is equal to 17.5. Right. Then value of resistor. What must be the value? So we have to find out the external resistance, whatever we are going to insert. So the equation will be like that way: E is equal to V plus IA into bracket R A plus R external. Okay. So for that way, we have to calculate first the back EMF, then we will calculate the whole, then we will calculate the value for R external. So let us start to solve. Okay. So see, as I told you, all the values are given. Armature resistance is given, that is here already mentioned. Voltage, it is mentioned here. Then speed, it is given here. Okay. So all the values already they have mentioned. Okay. So again, armature current 17.5, right? So let us start for the solution. So as we know that EB is equal to V plus IARA. So this V can be written as a K A into phi. Okay. So plus IA, and this RA we can write it as a R only. We will write it as only R. Okay. So now let us solve. We know that 20. Okay. So that 200 it is given already. So this value we have to find out, plus IA is 17.5 multiplied by resistance is 0.4. Okay. So these values are already given in equation, given in example. Okay. So we have to just pick that values from the equation and we have to put it into here. Okay. So now once we will solve this, then Ka5 value we will get. So thus N will also, that N is not here. You can see that N is not here. Where is this N? This N is goes to the right hand side for the dividation. Okay. So from that equation, we will get the value for Ka5, that is equal to 193 by 1000. We can also write it as a 0.193 like that way. So now let us find out what will be the resistance. This is the RA and this is resistance which is required to insert. So we have to calculate the resistance which will be required to insert to obtain the speed at 600 rpm. So let us go for that one. So see what we will do. We will again rewrite the equation. Like that way. 200, it is 200 like that way. This equation we will rewrite, right? So here only the difference that here we have written N, we will just replace that here N1. So this Ka5, this value we had calculated here. So 200 minus this N1, this value is now being changed to the 600. So we will multiply this one. Then 17.5 into 0.04 plus R. Then R we have to calculate, right? So once we will this equation we will replace to left hand side. This multiplication will go for the division. So like that way, R is equal to, we can find out 4.42 ohm. You can try with your calculator also. Just try to solve, check whether it is correct or not. Do it fast. Is it correct? Whether 442 is correct answer? Okay, fine. So this is the correct answer. So like that way, we had solved this numerical, right? So option B, that is the 4.42 means 4.4, that is nearly equal. This will be the correct answer. Okay. If you have any doubts, you can ask. Okay. Just don't be just seated, right? If you have doubt, you can ask. Now this example we will take. So very interesting. Just enjoy the example, just write it down. Whatever the values are given, just write it down. So now here, a 220 volt DC has armature resistance. Okay, what is that? Tell me, what is this value? What is this value? Anyone, just unmute and tell me. 1 ohm is nothing but armature resistance. 220 volt is nothing but voltage, right? And if the full load current, that is the full load current means IL, IA is given. Okay, that is 20 ampere. The difference in the induced voltage when machine is running as a motor, as a generator means, just try to understand the questions concern. Whenever you have 220 volt DC motor which having armature resistance of the 1 ohm and a full load current of 20 ampere, and when we connect this as a motor and when we connect it as a generator, then what will be the difference between the induced voltage? Okay, fine. So now let us go for the solution. First we will consider that it is a motor. So if it is a motor, that back EMF will be present, armature resistance shown here, the full load current that is coming 20 ampere and 1 ohm is armature resistance, also 220 is given. So now as we know that V is equal to EB minus IARA. EB minus IARA. So what is the value of EB? EB is nothing but what? How much is the value? So we can easily calculate that I think there is a small just a second. Yeah, it will be plus, right? It is plus. So Vt is equal to Eb plus IRA, right? So from that we can calculate that Eb value, that Eb is equal to V of t minus IARA. So what is the V of t? That is the 220. What is the value of IRA? That will be the 20 multiplied by 1. That is 20. So around we will get back EMF is equal to 200 volt. So that is the value for back EMF. So the back EMF is nothing but what? That is the induced voltage, right? Then go for the generator. So only difference is that EB is equal to, what is the difference? EB is equal to Vt plus IARE. That is the difference. What is difference? The only difference is plus and minus, right? So here again Vt is equal to 220 plus IRA will be nothing but 20. So overall voltage, conditional voltage in case of the generator, that will be 240, right? Now what they have asked us, what is the difference in induced voltage when machine run as motor, when machine run as generator? So what is the difference? Machine run as a generator voltage is 240 and machine run as a motor at that time is 220. So what will be the difference? 40 will be the difference, right? Am I right or wrong?
Yes,
So yes. So the option will be, which will be the correct option? C will be the
C.
option. Yes. So that is very simple. Okay. It is very simple that you should go for that. Okay. Uh, so is there any doubt in this problem?
No, sir.
Okay, fine. Can we go for another?
Yes.
Yes, sir.
Okay, fine. So the next for example is in front of you. Yes. We will read the example. Anyone interested? Yes. Read if anyone is interested.
A 200-volt DC series motor, when operating from rated voltage while driving a certain load, draws 10 ampere current and runs at 1000 rpm. The total series resistance is 1 ohm. The magnetic circuit is assumed at the same supply voltage. The load torque is increased by 44%. The speed of the motor in rpm.
Very good.
Put it to the nearest integer.
Yes. So see, as I told you, there is a two type of questions in a GATE examination. First type, I'll tell you, and then there is a second type. Okay, so in first type, the questions which will be asked based on the MCQs. Question will be asked on MCQs. So if there is a 1 mark MCQ question, then there is a 1/3 uh, what we can say reduction. Okay, negative marking is there. If the question is of 2 marks, then there is a 2/3 negative markings. Means suppose you have solved one right question you have solved, you will get 1 mark if it is a 1 mark question. For 2 mark question, if you solve one right question, then you will get 2 marks. But suppose another question you will miss, in also this one also, if you fail to solve correctly another question, then that time your 0.66 marks will be reduced, and in this 1 mark question 0.33 marks will be reduced. Okay, just keep in mind. So this is the MCQ type questions. But another type of question, so till now whatever questions we have seen, this all like a MCQ type. But the second type is a numerical questions. That is the numerical question. So in that type of examples, what you have to do, we have to solve the example, you have to find out the answer, and you have to put that answer into the box. Okay, so it may be right or it may be wrong. Okay, but there is no negative marking to these questions. There is no negative marking. Okay, so and now whatever the question is in front of you, that is around, that is from the type 2 questions. So that is the numerical question, right? So if suppose you have solved the numericals and you got the answer, then you can just put the answers here. Okay, so again there is one condition, that answer should be plus minus 3%. That may be for 3%. Means how much change? Means 0.03. That much change is allowed. Means suppose you have solved the numerical and you got the answer as a 101. Okay, that is the answer. Okay, that is the right answer. So you can write this like a 100.97. Either you can write 10.03. Okay, so your answer should be in between this range. Your answer should be in between this range. Okay, am I clear? Is that clear to all?
Yes, sir.
Okay, so now the whatever questions we are looking for here, that is based on the type 2 questions. Okay, so we'll go for the type 2. See, the first thing, we will just take an art whenever the data is given, what they exactly expected from us. So there is a armature current, so that is given armature current, right? Then from that armature current, let us calculate value for the back EMF. So that back EMF can be calculated with the help of the equation V minus IA RA, right? V minus IA RA. So what is the value of V? So V is nothing but 200 volt, right? V is 200 volt. What is the value of armature current? That is 10. Armature resistance, that is given 1 ampere. So your total back EMF will nothing but 190. That is the E1. So it is taken here. Now the next, just read next. The magnetic circuit is assumed to be linear. Okay, at the same supply voltage, the load torque is increased by 44%. The speed of motor. Now see which type of motor is given. Yes, anybody can tell me which type of motor is this?
DC series.
Just now tell me what is the relation between torque and armature current in case of series motor. What is the relation? It is directly proportional to the square of armature current. Am I right?
Yes.
Yes. Also, it is a linear magnetization. So, as we know that, if suppose torque is increased by 44%, means what? If 100 is a first torque, the next torque will be 144. Am I right? बरोबर बोलतोय का मी? जर सुरुवातीला टॉर्क 100 असेल तर तो इन्क्रीज केल्यानंतर सेम सप्लाय व्होल्टेजला किती सांगितलंय त्यांनी 44% ने, म्हणजे 100 वरती 44 म्हणजे किती होणार तो टॉर्क 144 होणार की नाही?
Yes, sir.
Yes,
Yes.
yes. Now we will, yes. So if suppose we will consider that T1 is a torque which is a 1, then what will be the T2? That T2 is nothing but 1.44 T1. Am I right? Am I right?
Yes, sir.
That T2 means next stop. So that is given here like a T2 is equal to 1.44 into T1. Okay. Then mm, then just look after the next, that is T into Ia square. That means T is directly proportional to the square of armature resistance. Okay. So here we know that this T2 we can write like this way. Uh, we can replace this T2 into Ia. So only what we will do, whether T2 is there, we will consider it is Ia2 square. So this in this equation we will replace Ia square instead of T. Okay, so here 1.44 Ia1 square. Ia1 square. Okay, now what we will do, we will take a square root of both sides. So this side we will get Ia2. 1.44 square root is 1.2 and Ia1 square, that is square root Ia1. Okay, so that means now here again what another things they had given to us? Is there anything? So here you know Ia1 value. Do you know the value of Ia1? How much is it? Is 10 ampere. So we will take the 10 ampere. So 1.2 into 10, we will get the value for armature current at second time when load torque is increased. Is that clear? Is that clear?
Yes, sir. Yes, sir.
Now we know the value of Ia2, we know the value of resistance, then we can go for the back EMF T2. So that is equal to V minus, V is nothing but 200 minus Ia, that is nothing but now change, that is 12 ampere, and the resistance is same, so 188 volt. Okay, so this is the change. Now what is the question? The speed of motor in RPM. So speed of motor we have to calculate, so that is why we will take this equation. E2 by E1 is equal to 5 by phi1 into N2 by N1. So now from that equation which values are known? So this phi2 phi1 we can write as a Ia2 Ia1, right? Because we know that torque is directly proportional to the phi into Ia in case of series motor. So this phi A, that phi nothing but Ia. So that it will become T is directly proportional to the Ia square. So we will take Ia2 Ia1. So what is the value of Ia2? That is a 12. What is value of Ia1? That is a 10. Okay. And what is the value of speed? That N1 is given as a 1000 RPM. What is the speed which will get us after the load increased by the 44%? So that we will calculate, and that load speed is nothing but 824.56. So as they told us, round us to the nearest integer. So we can write it. It is a above 50. At 0.50, above 0.50. So we will take next integer. So that is 825 rpm. If they had not given like that way, if suppose they had not mentioned that rounded figure, then you can go for simply the answer whatever you got, 824.567. Always go for the 2 or 3 digit. Always go for the 2 or 3 digit after the dot. Okay, keep in mind. So any doubt again here? Is there any doubt, anyone? Yes, anyone? Any doubt? Everyone, is it clear?
Yes, sir. Yes, sir.
Okay, okay, fine. Shall we go for the next?
Yes, sir.
Okay. Now again, this is the next example. Again, it is based on the numerical type and also what they had told. A separately excited DC motor has armature resistance of 0.05. Okay, and the field excitation is kept a constant. At an armature voltage of 100 volt, the motor produces torque of 500 Newton meter at a zero speed. Neglecting all mechanical losses, the no load speed of motor in radians for an armature voltage of 150 volt is. So very good question, isn't it? So what is the expectation? So they had asked a separately DC motor is given with armature resistance. Also told us that about the excitation is constant. Armature voltage is given. Motor torque is given at zero speed, and also asked a no load speed of motor in radians per second for that armature voltage of 150 volt. Here armature voltage is given 100, but asked for the 150. So let us go for the solution. C at zero speed, at omega is equal to 0. So if you know, if motor is at zero speed, then what is the back EMF? The motor zero speed losses, then what will be the back EMF? It is also 0, right?
Yes.
Am I right?
Yes, sir.
If the speed is 0, back EMF is also 0. So now we know that E is equal to V minus IRA. Sorry. In case of the DC motor, we know that V is equal to E plus IRA. Am I right? Now here we can find out the value for IA. So how? That V minus E divided by IE. Sorry, RE. Okay. So what is the value of V? V is given 100. 100 minus. What is the value of back EMF? That is 0. What is the value of RA? That is the 0.05. So once you will calculate that 100 divided by 0.05, you will get 2000 amp. Okay. Now, next stage. We know T is directly proportional to the phi IA, right? So we can write that is equal T is equal to K into phi IA. We can write it like that. So we have the value. So here the torque is given 500. So what we will do? We will calculate value for the K phi, because already we have calculated IA value. So K phi is equal to T divided by IA. T divided by IA. So T value is 500 and armature current is nothing but 2000. So K phi will be equal to 1 by 4. Now, as they had told us separately excited motor and also told that field excitation is constant, means that K phi will be the constant. That K phi 1 by 4 will be a constant value. That will not going to change. Okay. Then no load speed of motor. No load means what? Is there any current? As there is a no load, that means your current will become 0. Am I clear? Yes. So voltage, we again this formula we have here. V, if suppose the IA is 0, then this whole term will be 0. That means your V is equal to T. Is that clear? Is it clear?
Yes,
If
sir.
you are, yes, so that V is equal to E. So what is V? How much voltage is given? 150 volt. But what is the value for E? How we can write E? E we can write K phi into omega m. Okay. Again we know that K phi is a constant. Means already we had calculated value of K phi that will remain same. So we can take K phi here. So 120, 150 is equal to 1 by 4 omega m, and that 4 will goes to the multiplication. So what will be the value for omega m?
600 radians.
600 radians per second. Is there any doubt? अवगढ़ है कहें? Is it out? Is it impossible? It is very easy. Okay, it is not that much hard. So you have to just go follow the one by one. Every step you have to follow only, right? Okay, just read this example. Who will read? Who will read the example?
220 volt 10 kilowatt 900 RPM separately excited DC motor has an armature resistance RA is equal to 0.02 ohm when the motor operates at a rated speed and with rated terminal voltage. The electromagnetic torque developed by the motor is 7 Newton meter, neglecting the rotational losses of the machine. The current drawn by the motor from the 220 volt supply is
Okay, fine. So a 220 volt, 10 kilowatt, 900 RPM separately excited DC motor has an armature resistance 0.02. So like that way they had given this data. When the motor operates at rated speed, okay, and rated terminal voltage, that time whatever the torque is developing, that is 17 Newton meter. Again neglecting mechanical or rotational losses in machine, current drawn by the motor from 220 volt supply is. So this will be the homework example. Okay. So you will solve this example for whenever we will coming for the tomorrow's lecture. Just come up with the uh, whatever the answer is right, and I will personally check everyone's answer. Okay, and whatever it may be correct or it may be wrong. In any answer it will be, but you have to solve this, go step by step. Okay, just whatever the recent example we had seen, like that way this example is also. Okay, so just go for that one for the homework. Okay, so all should just mark your attendance. All should immediately mark your attendance and you can close the class. Those who have marked their attendance can leave. Akanksha, have you marked
Yes,
your
sir.
attendance? You can leave.
Okay.
Rutuja, you also. Ade, those who have marked attendance, please leave the class.